Today I'm going to teach you how you can use OpenAI's function calling feature to return perfect structured data from your OpenAI calls. Hi, I'm Ed Zynda, and this is What the Funk. Recently, OpenAI released a brand new feature called function calling. This allows developers using the OpenAI API to describe a set of functions, send those functions as part of the LLM call, and the LLM, either GPT 3.5 Turbo or GPT-4, can intelligently decide which function call to use in order to perform the task requested. For example, you can have a prompt asking for a list of flights from Hamburg, Germany to Madrid, Spain. You can describe a function that takes a starting point, an ending point, and a date. Let's say you also want the ability to book a flight. You can describe another function that takes a flight number and a date. Now, given that you've asked for the flight details from Hamburg to Madrid, the LLM will take a look at those function definitions and decide to use the flight details function that you provided. The return response from OpenAI will be a function call to that flight details function. Now, the LLM has no ability to actually call or run functions, but what it can do is return the JSON describing that it wants to use the flight details function and the arguments perfectly formatted in JSON so that you can take those details and call the function yourself. The next step for the developer would be to call that function and then take the initial prompt and add the results of that function call to that prompt. OpenAI will take the entire prompt plus the function call plus the results of the function call and return a human readable answer. You can then continue by adding a second prompt to book the flight or a flight that it returns. OpenAI will then return a request to call the book flights function. Now, this is great for creating intelligent agents using OpenAI's LLMs. But another cool possibility that this feature actually opens up is the ability to return structured data for anything. Say, for example, you want to scan a bunch of unstructured documents. Each of these documents has data that you want to store for later, but you want to store that data in a structured way. What you can then do is define a dummy function, and that dummy function actually takes arguments, but those arguments are defined as a structured set of JSON that you actually want to use to store for later. So in this example, we're going to be building a resume scanner, which scans resumes either PDF or Word document format. It will pull out the relevant information and return that information in structured JSON. OpenAI thinks it's returning a function call, but we don't actually care. We just care about the arguments as part of that function call. We can then use those arguments to do something with that structured data. So we're going to build a very lightweight UI application that will let you upload your resume, scan the resume, and then return the results in a structured way. But first, if you're brand new around here at What the Funk, we talk about all things development related, whether that be blockchain, AI, or just plain coding. If that's something that you're into, consider subscribing to this channel and hit that bell notification icon so you can stay up to date whenever I post a new video. With that out of the way, let's get into it. So let's start by looking at the actual blog post that OpenAI released to describe their function calling feature. So basically, they've released an update to GPT 3.5 Turbo and GPT-4. Down here, they describe the function calling feature. So developers can now describe functions to GPT-4 0613, that's the date they released the model, and GPT 3.5 Turbo 0613, and have the model intelligently choose to output a JSON object containing arguments to call those functions. This is a new way to more reliably connect GPT's capabilities with external tools and APIs. These models have been fine-tuned to both detect when a function needs to be called, depending on the user's input, and to respond with JSON that adheres to the function's signature. Function calling allows developers to more reliably get structured data back from the model. So they give an example here. A user can create a prompt basically that says, email Anya to see if she wants to get coffee next Friday. And so you can create a function called send email that takes a to and then a body for the email. And you can also create a function that will handle what's the weather like in Boston. Get current weather is a function you would define, and then the arguments it would take would be location, units, Celsius, Fahrenheit. So you get the idea. So how do we actually describe these functions? Let's scroll down a bit. And in this step 1, they have they have call the model with functions and the user's input. And so here you can see that basically you send a message to the OpenAI completions API. And so you have different types of messages that you can send to GPT 3.5 Turbo. So you have this messages array, and the messages array can take user messages and system messages. So user messages is basically the prompt example, what's the weather like in Boston? And then you also have this functions array. And the functions array only takes a set of objects that describes the function. So here you have a get current weather function. The description, it describes the function to ChatGPT or GPT-4, and then ChatGPT can use the description to decide whether or not this function will be useful in obtaining an answer for the query. Then the final step is this parameters. Parameters is an object, and then the object has some properties, and then these properties are the actual arguments that are going to be used in the function call when the OpenAI returns this data back to you. So you have a location, it's going to be a string, type string, and you can also define whether or not certain properties are required. So in this case, the location property is required. And that's basically it. But in our example, we're just going to define a single function. This single function is going to be something like scan resume. And then these properties for our dummy function are going to be the actual data that we want returned in a structured way. And you'll see that once we jump into the code. So here I have an empty project. I've created a .env file. This is where I'm going to store my OpenAPI key. And I've created an app.py file. This is going to be our UI app. And we're going to be using a tool called Streamlit, which allows you to easily create UIs for Python applications. And I'll show you how easy it is in a sec, and you'll just fall in love with it, I'm sure. I'm going to go ahead and add my API key off the screen so you don't see it, and then we can start setting up our dependencies. So in my terminal, I'm going to need to create a virtual environment. I personally am not a Python expert, but I know that it's better to create a virtual environment for all of your Python applications so you don't run into dependency conflicts when you're installing libraries. There are several ways to manage Python dependencies. In my case, I'm going to be using a tool called Anaconda, and it has a command line tool called Conda, which creates virtual environments, and you can activate that virtual environment after creating it. Feel free to use whatever Python virtual environment manager you feel comfortable with. So I'll create an environment called resume scanner demo, hit yes to proceed, and then run conda activate resume scanner demo. Next, we need to install some dependencies. We're going to install docx to txt, which will handle Word documents, langchain, py-pdf2 to handle our PDFs, python.env to handle our .env environment variables, and the Streamlit library. Now that those are installed, we can start coding. So in our app.py file, we import a bunch of dependencies. We import the .env library so we can read our .env file, Streamlit, py-pdf2, docx to txt, the langchain chat model so we can use the chat OpenAI, the langchain schema so we can format our messages in a way that OpenAI accepts. We're going to import the prompt template from LangChain as well as JSON so we can work with JSON. And then we've defined a main function, and this main function just loads our .env file. And then down here, basically all this says is once you are running this application, we want to call the main function. So this is the entry point for our application. Now I can go ahead and show how easy it is to get started with Streamlit. To start, I'm just going to add a simple header to our application. So we've loaded Streamlit using the alias st, and we can use this st.write function to write text to our application. And this write function acts as kind of a magic function, so you can pass in all kinds of things, files, images, text, and even markdown. So in this case, it's going to pass an h1 to our application. And let's go ahead and start the app to see what that looks like. To start a Streamlit application, you just use the Streamlit command, run, and then the Python file that contains the application. Now, if I open this local URL in our browser, you can see we have our app running already. So next we want to do a little bit of setup. Our app is going to scan a bunch of different resumes and it's going to pull the specified information from those resumes. So what do we want to actually pull? In our case, I think we'll start with the name, email, phone number. We're going to list any education they've put into the resume, employment history, and skills. And I think that should be enough. So in order to do that, we need to describe a dummy function to pass into OpenAI. The OpenAI call always takes function descriptions as an array. So let's create an empty array. Next, we can create an object, give it a name. In this case, our function is called scanResume. And the description is scans a resume and returns relevant information. So now we need to describe the data that we want returned. And so we're going to do this in the parameters object. It's of type object, and this object takes some properties. So first I've described name, email, and phone number, and these are all pretty simple. We've given it type string for each of these, and then we've given each a description. These descriptions, like I said before, these will help the LLM decide what kind of information to place where. So we've described the name as the name of the person, email as email of the person, and phone number as phone number of the person. Now for the education property, this is going to be an array because a person could have attended various different educational institutions. So we want to track every one of those. So we've passed the name, education, type as array, and then each array will take a set of items. Each of these will be an object, and each object has their own properties. So we want to know about the school, and we give it a type of string. The description is the name of the school. Each school will either give out a degree or some sort of certificate, so we give that, and then a time period. So from 2001 to 2004, for example, and we want to list all of that in the education array. We also give it a description that says education of the person. Similarly, we create an employment array, and this has a bunch of items with properties of the company name, the title, so CEO, manager, dishwasher, whatever, and then also a time period. We also give it a description, employment history of the person. Finally, we want a set of skills, and this is also an array, and the skills is just a simple array of strings with a description, skills of the person. To help out the LLM, we added a few required fields. So for every resume, there should always be a name, an email, and skills. The resume may or may not have education or employment history. Next, we're going to create a template to use for our prompting, and this will be used later on by LangChain to format our prompt using the text of the resume. So our initial prompt is scan the following resume and return the relevant details. If the data is missing, just return n/a. And then we have a placeholder for resume, and this is where we're going to replace the text of our resume and add it to the prompt. Next, we're going to set a setting in our Streamlit app. We want to go to the menu at the top right, click on settings, and then we want to click run on save. This will allow us to see the results and updates as we are editing our app, and creates for a better development experience. So back in our file, let's create a subheader called upload your resume and a section called status. We can create a placeholder for this area with the st.empty method. This is where we're going to show whether or not the upload was successful. Next, we can add a file uploader using the st_file_uploader method, and you just give it a little label and then the type of files that we want to accept. So in this case, PDF and Word document. And you can see how easy Streamlit makes it to create user interfaces. We've already got a file uploader UI element right in the app without really doing any coding at all. And next, I want to create a details placeholder, and this is where we're going to show all of the details that we've extracted from our resume. Now, in order to scan our resume, we're going to need to initialize the chat OpenAI model. We can initialize it here at the top after the load.env and store it in this LLM variable. We're going to be using GPT-4 0613. It's the most expensive model they have, but it's a very good model. You can also do this with ChatGPT 3.5 Turbo and I think it might do just as good of a job. Your mileage may vary, so you're going to want to test with the different models to see what works best for you. Next, we want to check whether or not the user has uploaded a file. So we check this by saying if file is not none, and then creating a block. Next, we'll create a notification spinner, and this lets the user know that the application is doing some work behind the scenes. And we've got this with keyword. I'm not super familiar with Python, but from what I've read, it's kind of like a try-catch block in JavaScript, if you're familiar with that. So anything within this block is going to wait to finish, and then when it's finished, this spinner will disappear. And then we're going to set our text to an empty string, and then we're going to load that text up later with the contents of our resume. We can go ahead and test that now. Here I've got a set of different resumes. We're gonna pick one of them, and you can see the file shows up, but the spinner doesn't show up. That's because we don't actually do anything super intensive. We just create this variable and it finishes, so it disappears immediately. So back in our code, let's check to see what kind of file we are uploading. So in the case of a PDF, we check if the file type is application/PDF. We use this PDF reader that we've imported at the top of our page. And then the way it works is the PDF reader gets a list of pages, and for every page, we basically extract the text, and then we'll load that into our text variable up here. And then for Word documents, the application type is a little long and cryptic. So it's this application/VND yada yada yada. It's something very hard to remember, but just in case, the source code for this application will be included in the description below this video. So no need to write this down. And just like in the PDF, we use a loader. So we use this docx to txt library that we imported at the top, and it uses this process method to read the file and then return the text. So we load that into our text variable. And then from template that we created above, this is from the LangChain library, and basically it will create a prompt, and then you can format the prompt using the argument that you specified in your template. So in this case, we specified a resume argument, and we can just pass in the text that we loaded from either the Word document or the PDF. And that creates the final content for our prompt. So now the meat and potatoes. The call to OpenAI is actually very simple using LangChain. So we have our LLM object, and all we need to do is call this predict messages method and pass in a human message with our prompt that we created, and then the array of functions, in this case our single function that only returns the details of our resume, and we store it in this response variable. And after that's all done, we can print out the results of our call. In this case, we'll just use the st.write method to print out the raw response. So let's upload a resume. You can see it's scanning. So it's sending the response off to OpenAI. So here you can see it spits out a bunch of JSON. But what's cool is it's all structured, and we can clean this up very easily. Now back in our app, I've done a little bit of cleanup. So I've taken the data and I've pulled the actual arguments, which is the only thing we care about, from this response.additional keyword args function call arguments, and I loaded that up as JSON. And to nicely format things in Streamlit, we can use this container method. So up here, remember, we've created this placeholder called details. And so in the details placeholder, I've created a container, and then I've created some headings and formatted everything out so it looks nice and pretty. And here you can see I've used a little bit of markdown for some bolded lists and then some sub lists. So let's go ahead and see what that looks like. Let's load this resume again, let it scan for a bit. Now that it's finished, you can see all the details in a nicely formatted manner. We can go ahead and compare these details to the actual resume. So name, Janine Nell, yeah, that's correct. The phone number, that also appears to be correct, and the email. And if we go ahead and look at education, so we can see she had a master's in industrial engineering at Harvard University, and we've got Harvard University Miami, master's in industrial engineering. If we scroll down to employment, she worked for Engine Oil. So we can see Engine Oil, she was a sales engineer, and yep, that matches. And for skills, she's got her skills listed all the way over here on the side. So AutoCAD, industry trends and sales forecasting, engineering. Yep, all of those seem to match. Back in our app, there's one thing I forgot to add a nice pretty success message. So you don't really need to add this. I just wanted to add it for completeness sake. Let's go ahead and try one more resume. In this case, we're going to load up a Word document, scanning once more. Now you can see our pretty success message, and you can see the data that's been extracted from our resume. We can go ahead and do a quick comparison. Yep, John Smith, email looks correct, phone number looks correct, education, Masters of Business Administration, University of Connecticut. We go down to professional experience. We can see Chief Financial Officer. Yep, Chief Financial Officer at, looks like Odichem Inc. And yeah, it looks like everything works as expected. And that's it. That's how you can use the power of OpenAI function calling, Streamlit, and Python to easily scan unstructured documents and return structured data. If you enjoyed this video, make sure to smash that like button. If you have any comments or questions, leave them down below. Once again, thanks for watching, and I'll see you in the next video.